Hi everyone. Today we're going to look at a problem from the topic linear programming. We're going to solve a problem and then we'll see what is really meant by linear programming. Linear programming, as we explained the previous time, is a kind of method they apply in various disciplines, in the manufacturing, in the medical field, engineering field, and the whole essence of it is just to maximize profits. In a manufacturing domain, we normally use the word optimize. That's when you want to optimize, you want to cut certain things, increase certain things in order for you to make more profits. So optimization, we call it in manufacturing field. It means before you apply linear programming somewhere, there is already a system in place. What linear programming comes to do is just to make improvements upon what is already in place. So here we look at a problem. But because of time constraints on these platforms we are using, Facebook, Instagram, and the rest, if you want to follow the full lessons, you want to get the full version of this lesson, you follow me on YouTube. This is my address there, or this is my channel, MUNIRRMKTURAY. When you just type this on the chat tab on your YouTube browser, then you will see these videos. Then you can be able to watch the full version of it. Here they're gonna cut it maybe 5-10 minutes. You're not gonna see everything. So this is a problem here. I will read the problem. I haven't got time, no space, to write the entire problem on the board. The board is small. We've got to also solve the problem here. But before I read the problem, I want to explain that when you want to solve a linear program problem, there are various methods to use, different methods to use in solving a linear program problem. But the common ones, mostly that are used, are the graph method. You can solve a linear program using a graph method. And also another method they call the simplex method. Simplex method, again, it comes with versions, but the most recommended one is the tabular form. You use the simplex method doing a tabular form. Don't get me wrong, there are other methods, but these are the most convenient ones. Other ones might be tedious, especially when algebra is involved, because these are equations sometimes with 3 unknowns, 4 unknowns, 5 unknowns. So when you just want to do algebra there, it becomes very tedious and complicated. So that's why those methods, the tabular form, the simplex method, is more convenient than using matrices. So now let's read the problem and then we'll try to solve it step by step. The problem reads: a small company makes module cars and planes, aeroplanes. That is like toy cars, toy planes, something like that, module cars. A module car takes 2 hours to construct and 3 hours to paint. A module plane takes 6 hours to construct and 3 hours to paint. Each week, there are 48 hours available for construction and 30 hours available for painting. The company sells a car for £50 and a plane for £90 and can sell all the modules it produces. The only cost is labor at £8 an hour for both types of work. How many cars and planes should the company make to maximize its weekly profits? So this is the question here. The module car, it takes them 2 hours to assemble it or construct it. For the module aeroplane, it takes 6 hours to construct it. For the car, it takes 3 hours to paint, and the aeroplane also takes the same amount of time to paint it. Each one, we are talking about each of these two things they are making in this factory. Then the company sells a car for £50 and an aeroplane for £90. And the cost, that's the labor, the people they employ, the manual labor, they pay £8 an hour for both types of work. The cost of producing a car is 40. So it costs them £40 to make a single model car. But they sell it £50, so they already make £10 profit. Yeah? So they have £10 profit here, market. And for an aeroplane, it costs them £90 to produce one, and they sell it at £72. So they already have £18 profit for each model plane they make and sell. So under these conditions, whatever they use when you are doing linear programming problems, what they call constraints, that is the things that are all into play. Maybe here you can take off how much they spend for the electricity, the water, and the labor they pay, and other things. So that is where you get your constraints, what is actually brought into place to produce that amount of profit. These are your constraints. So your constraint equations are given here, two equations. If they make X cars and Y aeroplanes, so 2 X cars and 6 aeroplanes, they will make a profit £48. If they make 3 cars and 3 aeroplanes, they will make a profit of £30. So these are your constraints. X greater than 0, Y greater than 0. It cannot be 0. They have to make something to get money. So now, after having all this, now your problem starts. The question says, how many cars and planes should the company make to maximize its weekly profits? So let us assume that the company makes X cars and Y planes each week. Let us make that assumption. Yeah? We are saying here that let that equation be Z equals to, they make X cars and Y planes each week. So now, this Z, from here, from this information here we have, this is where we are going to construct our objective function. The objective function is what we manipulate to make the profits, to make more profit. There is already profits, because the whole essence of linear program, I said there is something going wrong, you want to correct it. Or maybe in an industrial scale, you are making something, but you have a lot of defects. Some parts are broken, some things are missing. You want to minimize that. In that case, you want to minimize a loss. You are minimizing a loss. But when you want to make profit, you maximize your profit. So in linear program, you can minimize, you can also maximize. It depends what problem is put in place in front of you. Okay? So now, we say, let the company make X cars and Y aeroplanes. So because they are making a profit here of £10 for the aeroplanes, so it's going to be for the cars, 10x. And they're making £18 profits on every single aeroplane they make, because it costs them £90 and it costs them £72 to make, to assemble it, but they sell it at 90, so it's £18 profit. So this is your objective function. After calculating how much they invest and how much they earn, from there you work out your objective function. So when you get this one, you get your constraints. Now I can be able to erase more writing, and then we get enough space. So I'll take this off. Take this off, and what we have now, we have our objective function, which is z equals 10x plus 18y, and we have our constraints 2x plus 6y greater than or equal to less than or equal to 48, and 3x plus 3y less than or equal to 30. So this is all we need. Now you are asked to maximize. You have these three equations. Now they ask you to maximize, to make them get more profits. And you want to use the graph method. So let us draw our coordinate axis, the Cartesian coordinate. You have here I put it straight. So let's say here is 2, 4, 6, 8, 10. It's too close. Two, 4. Let me see, 4, 8. 12, 14, 16, and this is your y-axis. This is not straight. See? Then again you have 2, 4, 6, 8, 10, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42. So this is 2, 4, 6, 8, 10, 12, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40. And this is your x-axis. Yeah? So now we're going to plot these two lines here. When you look at these lines, you know these are straight lines. Linear programs, the lines have to be straight graph. So we've got to convert this equation or modify it to 2x plus 6y equals 48. Yeah? Because these are inequalities. If we use the other method, which is the simplex method, then we'll go to introduce slack variables here because we are changing inequality sign to an equality sign. And we can see these two equations are not exactly the same. This was less than or equal to 48. Now we are saying it's equal to 48. So they're not exactly the same. That's why when you do the tabular simplex method, we add another variable here, another unknown here, slack variable they call it, to compensate for this inequality sign and equal sign we are changing. Yeah? So this again, it becomes here 3x plus 3y equals 30. So now graphing. How do we graph these two equations on this Cartesian coordinate? How do you go about that? You all know. If we let's consider this equation first, equation 1 first. If we let x equal to 0, then we'll have 2 times 0 plus 6y equals 40. That is by letting x equal to 0. So this will be, this 48, sorry, should be 48. 48. So now 2 times 0 is 0. Now you will have 6y equals 48. So now you divide by 6, divide here by 6. So this now will give you, this will cancel. So now you have y equals 6 times 8 is 48. So you get 8 here. So when x is 0, y is 8. So when x is 0, along this line, x is 0. Along this line, y is 0. So when x is 0, y is 8. So we have a point here. When x is 0, y is 8. That is this point here. So now let's say when y is 0 this time. So now we have 2x plus 6. We let y equal to 0. This is 48. So this will be now 2x, 6 times 0 is 0, equals 48. So x now will divide both sides by 2. That's by 2. This will cancel. So this now will give us 24. This one here, 2, 24. So x is 24. So when y is 0, x is 24. Along this line, the y coordinate is 0. So when y is 0, x is 24. So we have 1 here, another point here. Let me use the red marker so that. Yeah? So now we use a straight line to join these 2 points. To join them. Oh, fall short. Anyway, but you get the idea. That is the most important thing. This is the line. This is the graph. 2y plus 2x plus 6y equals 48. That's the graph. Okay. We are using graphing techniques. Now let's consider the second problem. The second equation now says that this one now, number 2, 3y plus 3x plus 3y equals 30. So if x is 0, that you will have 3 times 0 plus 3y equals 30. So this is 0 plus 3y equals 30. So now you divide both sides by 3. Now you have 3y equals 30. If you divide by 3, you get in over 3 over 3. So now y will be y equals to 3 here, you get 10. So y is 10. So when x is 0, y is 10. When x is 0, y is 10. And now again, because it's all 3, 3, when y is 0, x is 10. Because it's all 3 plus 3, so they're going to do the same thing. So now again, we'll draw a line here. You can draw a straight line. Yep. Well, get it. So these are the 2 lines from that graph. But we know that, according to the equation we have, this one says 2x plus 6y, which is this equation. 2x plus 6y, what did it say? Is less than or equal to 48. And for this one, this other equation is 3x plus 3y less than or equal to 30. Correct? So since it is less than, it means anything below this line, this equation, for this equation, anything below it satisfies this condition, less than 48. So anything here below this line satisfies this equation. And as well as this other one, anything below it, this line here, anything below it satisfies the equation. So this area that satisfies these 2 equations is what we call the feasible region. That is, there is a solution because it's been bounded from above. So then we can get a solution. If this area was not bounded, say this area was up, these equations are here, but all this area here unbounded was above, then you cannot solve that problem, that linear programming problem. You cannot maximize profits. It's just not possible again to do anything. Yeah? So now, we now see where these 2 equations meet. Yeah? These 2 lines meet. Sorry, hold on. Go and sit down. Sorry for the interruption. So now we look at all this area that is governed by these two equations. So now we can say this area here is our solution. This is the feasible area where these two lines intersect. All what is underneath it, that is our feasible area. That is the solution here. But how do you find specific solution? Now, these two lines meet here. If you drop a line, why don't I put? You can see it's here. And if you drop another line here where they intersect, so they meet at these 2 points. My lines are not perfect, so we are just following the graph. So you can see that they intersect here at y equals 7, and the two lines intersect on the x-axis at y equals 5. Yeah, 2, 4, 5. My lines are not correct. This is just an estimate. The gradation is not even. It's not equal. You see, these are too big. These are too close next to each other. So what that means, for you to get your final answer, to maximize, so now you come back to your original objective function. The objective function says z is equals to 10x plus 18y. So we now have 10x, and x in this case is 5 plus 18y, and y here we have 7 plus 18 y is 7, 18y. But what this has already indicated to us is that they got to make 7 aeroplanes and 5 cars every week for them to maximize their profits. That's what this equation tells us. The intersect here on the x-axis is 5, on the y-axis is 7. But we know x, before we said the number of cars, and y was for the number of aeroplanes from our objective function. So therefore, they need to make 7 aeroplanes per week and 5 cars per week in order for them to increase their profit. And by how much? So if you just calculate this one, 10 times 5, z is equals to 10 times 5 is 50, plus now 18 times 7. 7 times 7, this is 56, you carry 5. This is 7, 12, 126. So plus 126. So then this is 176 pounds. So their profit has increased to 176 pounds a week. How much were they getting? For each car, it was 10 pounds and 18 pounds. You know? So that's the solution to this problem. We shall solve this problem with the other method, the simplex method, the tabular form. We shall solve it using that method. These answers are not correct because of my graph is not perfect. It should actually be 3 here, I think. Let me check. Yeah, 3. 3 and 7. 2, 4. It should be 3 here. If I would have done this properly, this would have been 2, 4. So this should have been 3. So it should have been 10, 3 plus 18x, 18 times 7. But the solution, the method, is correct. Yeah? Just because I don't have a graph paper, something like that. So anyway, that is it. Thank you for watching.